about Dutch roll. Dutch roll is an aircraft motion that is identified by a combination of continuous back and forth rolling and yawing motion. In general, a Dutch roll is considered to be dynamically stable, meaning that the oscillations tends to decrease in amplitude. Most larger airlines have a yaw damper installed that can be artificially increase stability. Aircraft that have wings placed above the center of mass, dihedral wings and swept wings, tend to increase the roll restoring force. Therefore, increase the tendency of the aircraft to initiate a Dutch roll. This is the reason why high-winged aircraft are often slightly anhedral and swept wing aircraft rely on the operation of the yaw damper. How the Dutch rolls occur? In aircraft design, relatively weaker positive directional stability as opposed to positive lateral stability can result in a Dutch roll. Rolling the aircraft around the longitudinal axis means that a slight slip is introduced in the relative wind in the direction of rolling motion. A strong lateral stability begins to restore the airplane to wings level position. Weaker directional stability attempts to correct the slight slip by aligning the aircraft with the perceived relative wind. Since the directional stability is weaker than the lateral stability for the aircraft, the restoring yaw motion lags significantly behind the restoring roll motion. The aircraft then passes through level flight as the yaw motion is continuing in the direction of the original roll. At this point, a side slip is introduced in the opposite direction and process is reversed. Periods can change from some seconds for light aircraft to several minutes for larger airlines. Dutch roll is also the name given to the coordination generally taught to student pilots to help them improve their stick and rudder technique. The aircraft is alternatively rolled as much as 60° left and right, while rudder is applied to keep the nose of the aircraft pointed to a fixed point. More correctly, this is a rudder coordination practice exercise to teach a student pilot how to correct for the effect known as adverse aileron yaw during roll inputs. The origin of the name Dutch roll is uncertain. However, it is likely that this term describing a lateral asymmetric motion of an airplane was borrowed from a reference to similar appearing motion in ice skating. In 1916, aeronautical engineer Jerome C. Hunker published the following quote: Dutch roll, the third element in the motion, is a yawing to the right and left combined with rolling. The motion is oscillatory of speed at 7 to 12 seconds, which may or may not be damped. The analogy to Dutch roll or outer edge in ice skating is obvious. In 1916, Dutch roll was the term used for ice skating repetitively to right and left on the outer edge of one's skates. By 1916, the term has been imported from skating to aeronautical engineering, perhaps by Hunsaker himself. In 1916 was only 5 years after G.H. Bryan did the first mathematical analysis of lateral motion of aircraft in 1911.
Hello everyone, I'm Niradeshwin from 3rd year Aerospace. Let's discuss a topic in flight dynamics, that is one engine inoperative condition. This is a condition where an engine failure during flight in multi-engine aircraft. The main problem is asymmetric thrust. That is the imbalance of thrust produced by an operating engine compared to the failed engine. This resulting yawing moment towards the failed engine. And this affects overall aircraft performance by reducing thrust and increasing drag due to asymmetric thrust and challenge to maintain straight flight. To counteract asymmetric thrust, pilots should have to apply rudder toward the operating engine and use aileron to control rolling moment and use trim to reduce workload. If this condition happens in a flight during flight, the first thing is to identify the failed engine and securing the failed engine by fuel cutoff and propeller feathering, and to maintain the control of the aircraft, then communicate with air traffic control to initiate appropriate action. Thank you.